Here's a question for a two-sample t-test, online versus in-store shopping. I am not going to do this calculation by hand and then look up the TCDF on a TI-84 because the significant standard deviations are different. That means I'd have to use a Welch's t-test to find the t-value. T-value for that is a pretty drawn-out by hand calculation. So I'm just going to find the values, enter them into a TI-84 calculator for a two-sample t-test. I'm just going to do this as a test, not do all that stuff by hand. If you'd like to do it by hand, take this question, upload it to ChatGPT or to Google Gemini, and it will give you the details of calculating the t-value using the Welch's t-test method. And you'll see how to do that. But I'm just going to use a TI-84. So I want the null hypothesis. The null hypothesis is use a four-step inference at alpha equals 0.05 significance level to determine whether there's a significant difference. So null hypothesis, no significant difference. And you can write the rest of it between average sales between online and in-store. And the alternate hypothesis, and this is why it's a two-sided, there is a significant difference. Okay, in other words, the mean of in-store minus the mean of online, the absolute value of that is equal to 0. In this case, the absolute value of them, the difference between them, is not equal 0. That's why it's a two-tailed test. Okay, so let's see. It's a random sample, good. It's got 100 transactions, and there's two different things going on there, two different samples. So it is a two-sample t-test. So now, if my p-value is less than 0.05, I will reject the null hypothesis. If my p-value is greater than 0.05, I will fail to reject null hypothesis. In that case, there will be convincing evidence to say that there is a significant difference between the average sales for online and in-store shopping. But okay, let me enter this into the TI-84 and see what it comes up with. So let me clear what's already on here, and I go to Stat, and I go to Tests, and I want to do a two-sample t-test. And I don't want to do data. I don't have data. I have stats. So now I'm going to put in my stats. I think they're already in here. I have 42.7. This is for online. 42.7 and 8.1. Got it. And the sample size is 100. For in-store, it is 46.3 and 9.2. Sample size is 100. For my... Oh, hold on. I've got to scroll down here. I want the not equal. It's not less than, not greater than. I want to see if they're not equal. And then for this pooled, if the variances, standard deviations are very close or the same, then they are pooled. If they're not the same, they're not pooled. These are quite different. That's why I'd have to use the Welch's t-test. That's why calculating the degrees of freedom is a drawn-out thing. So pooled, I have to say no. And then I go down here and calculate, and it's going to spit out the values. It says that the P is 0.0037, approximately. P is 0.0037. It's less than 0.05. Yes, that's less than 0.05. I will reject the null hypothesis. There is convincing evidence that there is a difference, that there is a significant difference in average sales between online and in-store. So there's the answer for that one. They're rejecting. There is convincing evidence that there is significant difference. In other words, the difference between the absolute value between the means of online and in-store shopping is not equal to 0. There is convincing evidence that there is a significant difference in the average sales between online and in-store. That's the answer, however you want to say it.